let's talk about factoring special cases. So we've touched on a little bit already about a difference of squares. So you need to know what perfect squares are, and we'll refresh back to what those are. So we know 1's a perfect square. Think about 1 times 1 gives me 1. 4 is a perfect square. Think about what number times itself gets me 4. Well, 2 times 2 gets me 4. 9, 16, 25, and so on. So you need to know your perfect squares to at least 144, like 12 times 12. So when first thing we're looking at is when we're doing difference of squares, we're looking to see is the first term a perfect square and is the last term a perfect square. If it is and it has a subtraction sign in the middle, then this is called a difference of squares. So immediately we go ahead and set up our two binomials. We know because there's no middle term that one of our signs is going to be positive and one is going to be negative. Because we have no middle term, the negative and positive cancel each other out. And then we're going to split up our perfect squares by taking the square root. So like the square root of x squared, at what times what gives me x squared? Well, x and x. And what times what gets me, or what times itself gets me 4? Well, 2 and 2. Then I want to check with FOIL. So x times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x. And then a positive and a negative give me a negative 4. Notice my middle terms cancel out, and I have back to where I started, which was the difference of perfect squares, or difference of squares. So that's one of our special cases we're going to work with. So when we start looking at example A, I'm going to look at my first term and my second term and see if it's perfect square. So is there anything times itself to get me 9? Well, yeah, 3. Anything times itself to get me 16? Yes. And notice that A is squared, so I can split A into 2 pieces. So immediately go to my binomials and go ahead and take the square root. Well, the square root of 9 is 3 and 3. Split up the A squared, so I get A, and the square root of 16 is 4 and 4. Because I have no middle term, I know one's got to be positive and one's got to be negative. Doesn't matter which one I put first. Now let's try B and C. See how quickly you can do them. All right, so B, 49 was a perfect square. B squared we can split up, and 144 is a perfect square. Signs, positive and negative, to have that middle term cancel out. So our factored form would be 7b plus 12 and 7b minus 12. For C, 625, if you don't remember how to, obviously 625 is not one you probably memorize, but to find the square root of something, remember you just use the square root in your calculator or on Desmos and just take the square root. You have to hit the second button on your calculator of 625 and you would get the answer of 25. So you can easily use your technology to help you find that. All right, so let's look at some perfect square trinomials. So we've learned already how to factor trinomials, and we talked about how when we look first, we look for a GCF. Well, I don't see a GCF. I could do the whole thing where I'm saying, okay, whatever my 1 is times, or my A times my C, I get 16. I can use my X method. And it has to equal 8. So I can find factors of 16. Well, factor of 16, I know that 4 times 4 gets me 16. Also add together, it gets me 8. So I can still use that method where I split up my x's, and I know I'm going to use factor of 4 and 4. And with this one, because I have positives, and my middle term's positive, I know both of these are going to be positive. So what I'm actually going to get is x plus 4 times x plus 4. I can check back and make sure it actually works, but it does. I can actually write this as x plus 4 squared. So either one of those is acceptable, but know that these are exactly the same. So I'm looking at the first and last term first. Instead of going through the x method, I always look for GCF. Now I'm going to look for the first and last term and see if they're perfect squares. So on example B, y squared, that's a perfect square, and 36 is a perfect square. So I think to myself, well, the square root of 36 is 6. If I add 6 plus 6, can I get 12? Yes. So immediately I'm going to go ahead and put my binomials, y and y. I have a 6 and a 6. I don't want middle terms to cancel out, obviously, because I have a middle term, and I need that middle term to be positive. So 6 plus a 6 is going to get me 12. I can also write this as y plus 6 squared. All right, let's try C. So C, I have a 16, a 24, and a 9. I always want to look to see if I have a GCF. I don't have a GCF that can come out of all of those, so I'm going to look to see if I have a perfect square. So 16, yes, it's a perfect square. A squared a perfect square? Yes. Is 9 a perfect square? Yes. So I'm going to go ahead and set up my binomials. Square root of 16 is 4. A split in half. So I have 4a on each. And then square root of 9 is 3 and 3. Now, I have to be careful here because I want my two terms, when they multiply, to get me a positive, but when I add them, to get me a negative. So I have to think about that. If I do 4 times 4 and get 16a squared, fantastic. But if I do 4a times 3, I get 12a. And I do 4 times 3, I get 12a. I need them to add up to be a negative, so a negative 24, and I need them to multiply to get me a positive. Well, I know that a negative times a negative is the only thing that's going to get me a positive. So this is my factored form, which I also can write as 4a minus 3 squared. All right, let's look at D. Perfect square, yes. I can split up b squared, yes. Perfect square, yes. Set my two binomials. Square root of 64 is 8. B split, so I know it's going to be 8b. Square root of 49 is 7 and 7. Now I'm going to look at my signs. I need, when I multiply, to get positive. So the only thing that can get me positive is a positive times a positive or a negative times a negative. But my middle term is positive. So obviously negatives together are not going to get me a positive when I add them. So I know both of these are going to be positive. So then I can also rewrite this as 8b plus 7 squared. All right, let's move on to some that do have GCFs. So we're looking first at GCFs. I always look for a GCF. So I do see a GCF, so I'm going to pull that out first. Pull out 2, rewrite. So I'm just factoring out the greatest common factor. Then I'm going to look at what I have inside my binomial and see if it's a perfect square. Well, x squared, perfect square, and 9 is a perfect square, and it's a difference of squares. So I'm going to factor this further. So I have an x and an x, a 3 and a 3, and because I don't have a middle term here, I know one's got to be negative and one's got to be positive. And I cannot forget to bring down my 2. So this would be my final answer. All right, let's look at B. Do I have a GCF? Yes. 3 can come out of 12, 3, and 12. So I'm going to pull it out. 3, end up with x squared minus 4x plus 4. Now I'm going to look closer. Do I have a perfect square? Yes. Perfect square? Yes. Go ahead and do my two binomials. I'm going to go ahead and pull my 3 down there. I have an x and an x, a 2 and a 2. I need to have positive here. So I'm either going to have a positive times a positive and get a positive, but I need a negative here. And a positive plus a positive is not going to ever get me a negative. So I need to have a negative and a negative because I need a negative 4x in the middle and I need a positive 4 at the end. So a negative 2 and a negative 2 multiply get me back to a positive 4. I can actually rewrite this as 3 times x minus 2 squared. Those are both acceptable. All right, let's try C. GCF first. Notice with this one, I actually can pull out an h as well. So I'm going to pull out a 4, because that can go into 36, h. And I end up with h squared left minus 9. Then I look, oh, this is a difference of squares. I'm going to head and put my two binomials, bring my greatest common factor down, have an h and an h, a 3 and a 3, no middle term, so one's positive and one's negative. This is my final answer. All right, let's do D. GCF? Yes. Pull it out and rewrite what's left. Then look, is this a perfect square? Yes. Perfect square? Yes. Do your two binomials. Split up your first term, a and a. Square root of 25 is 5 and 5. And I need a middle term, so I can't have one negative, one positive, and I need that middle term to be positive, so I know both of these have to be positive. This is positive and this is positive. So I can rewrite this as 2 times a plus 5 squared, and that would be acceptable answer as well. Now here are a couple reminders to help you with your signs. When you have difference of squares, you're going to have one positive and one negative. You'll split up those squares. When you have two positives and you have a middle term, you're basically going to have two positives. When you have a negative and a positive, you're going to have two negatives. So that's a quick little reminder to kind of help you when you're doing these special cases with perfect squares. All right, so we're going to go to some more advanced ones and see how we do with these. So you can pause. I'm going to put the answers pretty quickly, but you can pause and then come back and see how you did. All right, so for A and B, pretty straightforward. Now, we're going to see a little closer together. So we always look and see, do we have perfect squares? Well, 9's a perfect square, x squared we can split, and 25 is a perfect square. However, this is not a difference. This is a sum. It's not a difference. We cannot figure out, so if we try to break this into two binomials, we'd have 3x and 3x, and we'd have a 5 and a 5. And normally to get no middle term, we have a negative and a positive. That cancels out middle terms. However, if we have to multiply a negative times a positive, we're not going to get back to a positive. We're going to get a negative, so that won't work. If we put two positives, we're going to end up having a middle term. So this cannot work. This is a factor prime problem, so it's not factorable. We can't factor this anymore. It won't work. Okay? All right, let's look at D. You always want to see if you can pull out a GCF. Sometimes it's more evident than others. If you don't see it, you'll just know that you can factor further. So I'm going to do this one a little bit different, and I'm going to look and see, okay, that's a perfect square, that's a perfect square. I can actually split 4, because 4 is a perfect square, into two pieces. So I'm going to notice that this n to the 4th is written after, but it's still a difference, okay? So I'm going to do my two binomials. Square root of 16 is 4. Square root of 81 is 9. And then n4 split in 2 is n squared and n squared. Now, I have no middle term. This is different. So one's going to be a negative and one's going to be a positive. Now, when we look closer, if we think, oh, we're done, we need to look a little closer, this is a difference here. We can actually take and factor this further. This is a perfect square. This is also a perfect square. We can actually take this term and make it into two more binomials. We have a 2 and a 2, a 3n and a 3n. No middle term, so one's a positive and one's a negative. And then this whole term here has to come down. We couldn't do this one because it was a sum of perfect squares. So this would be our final answer, factored fully. So be careful with those. Always look for those GCFs. Look to see if you factored all the way, and look for those perfect squares to see if you can factor further.